Okay, let's go over some problems where we find the domain of a function. So I have some functions here, and I want to answer two questions about each function. Part A, for what values of x is the function undefined? And part B, what is the domain of the function? Express the answer in set builder notation or interval notation. Okay, so we need part A before we can do part B. You need to know where is your function undefined so that you can then figure out where it is defined, because the domain is all the values of x where the function does actually have a value. So all the values of x that we can plug in. So let's look at this first function here. Are there any problem values of x that will give me an undefined? Well, there's no denominators and there's no square roots. There's no other even roots like fourth roots. So there's no values of x that are a problem. Every value of x is good to go. So the answer for part A here is what values of x make the function undefined? None. Part B, then what is the domain of the function? This is all real values. So you could just say, like in set builder notation, x such that, all x, something like this, I guess. Or if you want to do it in interval notation, then I think it's a little more sensible. So we could go from negative infinity to infinity. If you guys know this symbol as well, you could use this. This is all real numbers. That would be a fine way to answer as well. All right, so for the second one here, let's see if it's a little bit trickier. Looks like I have a denominator, so yeah, this is going to be a little trickier. So for part A, where is this function undefined? What x make it undefined? It's going to be undefined when the denominator equals 0. So how do I know where does the denominator equal 0? We'll just set it equal to 0 and find out. That's what the point of an equation is, to tell us where this thing equals 0. Okay, so I want to know where does the denominator equal 0, then I'm going to solve this. And it's not very hard, so I'm going to get x equals 3 over 2. Okay, so that's the answer to part A. Where is the function undefined for what x values? And then for part B, what is the domain? So for the domain, I just have to throw away this bad x value. So my set builder notation, I can do it like this. So I want all the x's that are not equal to 3/2. So for set builder notation, I can just put a list of requirements after the line. Or if I want to do it with the interval notation, I would have to start from the lowest one would be negative infinity, and then come up to 3/2 and stop right before it. So use the curved parentheses here, so I'm not including 3/2. And then I would start again immediately after 3/2 and then go all the way to infinity. So whichever one of these you like better is completely fine. I think the first one is easier to understand. But if you don't remember set builder notation, then you might like the second one better. So the U here just means to include both of those intervals. Okay, let's look at the next one. So I don't see any denominators, so I'm not worried about that. But I do see a square root, and I know that the bad x values for a square root are the ones where they make what's in the square root less than 0, so negative. So I want to solve where is this square root contents less than 0? What makes x squared plus 1 less than 0? So let's try to solve this. Subtracting 1 from both sides, and then I guess I have to square root, but uh-oh. Now if we look at this here, isn't x squared always positive? So this is something that's always positive, and I'm asking, where is it negative? Where is it less than -1? That doesn't make sense. I don't think there's any x's that are going to make x squared less than -1. So this has no solutions. And so that means that there's no x values. There are no bad x values. Okay, so there are no x values I can plug into this function that will make the contents of that square root be negative. To look at it yourself, x squared plus 1, isn't that always going to be positive? Yeah, it is. So then the domain for this one is actually, it's all real values again, or you can write in interval notation like this. Okay, so then moving along. All right, so now we have another one where we have a square root. So there's no denominator, so I don't have to worry about where is the denominator 0, but I am worried about where could this contents of the square root be negative at. So to find out where this would be negative, I'm going to try to solve this inequality to just directly see where is this less than 0. So first I'm going to add 2x to both sides. So I get 1 is less than 2x. And then I think I just need to divide both sides by 2 to isolate x. So I'm going to do that. When you divide both sides by a positive number, it doesn't do anything weird. You can keep the inequality going the same direction, but if I were to divide or multiply by a negative number, then I have to reverse the direction of the inequality. Okay, so these are the x values that are going to give me an undefined. And you can check this yourself, like just try plugging in anything greater than 1/2 into this function, and then it's going to come out negative under there. So in set builder notation, this would be just x such that x is greater than 1/2. I'm just writing it backwards because I like the way it looks better. Or in interval notation, so greater than 1/2, so starting at 1/2, I'm not including 1/2, and then going to infinity. Either of these would be a fine way to answer. Then for part B, so the domain. All right, so these are the bad x values, so we want the opposite of these. So anything that is not greater than 1/2. So we can just take the opposite of this inequality, so it's going to be x less than or equal to 1/2. You could do it like that. Or you can do the opposite interval notation. So everything less than or equal to 1/2 is going to be like this. Okay, so we are including the 1/2 there because it was not included in part A. So part A and part B together need to cover all of the real numbers. So 1/2 had to be included in either part A or part B. Okay. I haven't been boxing these ones for part B for some of them because it was like the whole thing that I wrote. All right, number 5. Ooh, a tricky one. So we have a denominator and we have a square root. So I know that I want to figure out for part A, where is the contents of the square root less than 0, because that will be undefined. But I also need to figure out where is the denominator equal to 0, because that will be undefined as well. So I also need to check for this. Where do they equal 0? And it's nice that in this problem, it actually kind of turns out to be like you could unify this into one equation or one inequality, because if I square both sides here, then I get x minus 4 equals 0, and I could just turn this into one equation like this. That would be a fine way to do it, or you could keep them separate. It doesn't really matter too much. You should get the same solution either way. Okay, so maybe I'll just keep them separate and pretend like I'm just like a naive, sweet summer flower child. I don't know anything about anything. I'm just following the instructions I was given. So x needs to be less than 4. That's one way to make the denominator undefined, because if I put in anything less than 4 for that x, then I have a negative under the square root. And this one over here, if x is equal to 4, then I'm getting 0 in the denominator, which is also bad. So I can take the square root of 0, it's 0, but then I can't divide by that 0 and get that in the denominator. Okay, so the total answer here for part A is I can put this together into interval notation or set builder notation. So x such that x is less than 4 or x is equal to 4. We should combine these into one thing. I think it's kind of silly to write it separately like that. So at least at this point, hopefully you would realize that you can combine these. And then for part B, I want everything that is not in part A, so the opposite of part A, all the x values that are not less than or equal to 4, so that's going to be the ones that are greater than 4. Oh, and I can do interval notation for these as well. So for this one, it would be this, and then this one would be, oops, no, yeah, that was right, sorry. So 4 to infinity. All right, that's it for this type of question.